on va parler de choléra cet après-midi. Merci à Epicentre.
So we're going to focus on cholera this afternoon. Thank you very much to Epicentre and MSF to continue to dedicate some time during this meeting to a disease that is still very frequently encountered in our fields. More particularly because we've seen quite a number of outbreaks recently. Now, cholera is a very old disease, older than even the oldest Epicentre director. And it's so easy to control and prevent and treat that it always comes as a surprise when we are faced with an annual number of cases of 600,000 cases and 10,000 deaths, like we had last year. And 150 years ago, cholera was eliminated from Europe without any vaccines or antibiotics, so it can be prevented. Not so much a technical challenge as a political one and a commitment to control this disease. As we all know, this is a disease that is bound to occur in conflict areas, in underprivileged areas, in remote areas, difficult to access area. So this is why it's what we see on a daily basis at MSF and Epicentre. We have been given a list of MSF reports, and it's approximately 100 reports and papers published by Epicentre in the past years. Now, over the past 40 years, there were 4 major epidemics, and it's about the only time when the public opinion or the media pay attention to it. Now, in 1991, there was an outbreak in Peru, and it really flared at the time. I was in the field in Peru, and there were 400,000 cases, and a few years down the road, they had been able to eliminate it. Now, the other outbreak was in Goma in 1994, and it was really a big flare due to the tragic survival conditions for these people with 20,000 cases. And then in 2010, we were faced with the outbreak in Haiti, 800,000 cases, more than 10,000 people died there, and it's still ongoing. And then in 2017, the epidemic in Yemen with 2,500 cases, probably an overestimate, but there were approximately 4,000 deaths. So, and then every time there is a big epidemic, a large epidemic, then the media focus on it, and the GDF, the Global Task Force created, the GDFCC was created in 1981 by WHO at the time. And over this period of 1986 to 26, what is worth mentioning is the development of an oral vaccine, the OCV, well known to all of us now. Now, the first OCV was rolled out in 1991, and then gradually it was extended in the year 2000. The first feasibility study was carried out with Epicentre, and then there were further studies afterwards. However, the stockpile was created in 2013, and 215 million doses have been produced now. So this has been a game changer in cholera control. These RDTs have been widely validated now. It's not of course, the magic bullet, but it's much better than symptomatic surveillance alone. There's been also some work done on genotypes, showing that what we thought about this so-called pool of cholera Vibrio was not in fact true. And I could see from with my hat at WHO that Epicente's contribution was a major one in this regard. And then ending cholera by 2030, we didn't speak of or refer to eradication or elimination, but we were hoping to stop it, put an end to it. We could see some improvement until the year 2020, but now we have a worsening of the situation. So we need to pursue our political commitment, and I think we've been able to show that we know how to do that. We are going to get some information on this vaccine. It's not a miracle vaccine. It requires 2 doses. However, we managed to use it in very difficult settings. And of course, we would rather have a single-dose vaccine, much more convenient to use in our settings. And I do encourage MSF and Epicent to work on such a vaccine. And then RDT or RDTs, if we were able to use RDTs that would be more discriminating, then it would mean a lot. It would mean, of course, a major improvement to reduce mortality. 8,000 people died last year. So if we were able to improve RDT, it would be easier to have a more efficient management of patients. And I leave it there and give the floor to my colleague, Carol.
So we balance the introduction. We have just heard that MSF has a very long history with cholera. More recently, in the last 3 to 4 years, we really had, as an organization, to scale up the response in a context of global resurgence. As it was said, in 2025 alone, we had more than 600,000 cases and nearly 8,000 deaths that were reported globally across 33 countries. But these numbers are largely underestimated and does not represent the true burden of the disease globally. What is changing is not only the scale, but the pattern of the disease. We see a shift to more widespread transmission. The number of high-burden countries with the high-burden outbreaks with more than 10,000 cases has doubled over the last 3 years. We see more cross-border transmission. We see protracted outbreak with several waves. We see less predictability. We see outbreak in new contexts where that were not endemic or that had low endemicity. But in the end, the heaviest impact on cholera really happened in complex, fragile humanitarian setting. We had in 2025 massive outbreak to which most of the section from MSF responded in Sudan, in South Sudan, DRC, Yemen, Afghanistan. And maybe DRC, looking at this context specifically, because we will have one of the research that happened in these countries. It was the 2025 outbreak was described as the worst in the last 25 years. 76,000 cases, a CFR of 3%, and in those countries, this is where the CFR are usually the highest. Transmission that rapidly spread all over the countries in most provinces, including in previously non-endemic areas, and the outbreak driven by complex dynamics and compounded by many different competing priorities in a very complex setting. And yet, as it was said, cholera is preventable, cholera is treatable, and yet we do have a global cholera control strategy. We do have global coordination mechanism. We do know how to effectively respond to outbreak with early detection, timely, real-time monitoring, adaptation, rapid decentralized case management, vaccination, community engagement, hygiene promotion, and of course, lots of integration of WASH activities to control the outbreak. So the challenge, as it was said, is not so much about what to do, but actually how we can do that in those very, very complex humanitarian contexts where we have competing priorities, multi-risk, climate impacts, massive displacement of population, and very, very severe access constraints, looking at insecurity, misinformation, infrastructure damage, regulatory challenges. So each of these contexts really force us different trade-off and require some flexibility. We really must adapt. We need to unlearn and relearn, rethink how we do things. We need and we must innovate with new medical countermeasures, with new operational model, and with new way on how we can improve care and reduce mortality, especially in those contexts. So this is where operational research is essential, not as a scientific exercise, but really as a tool to guide these difficult decisions in those contexts and to push the boundaries to improve coverage and quality of the care that we deliver for those vulnerable populations. To set the scene, we have now two presentations that speak directly to one of the control tool, which is OCV. As a little bit of background, 3 elements. First, since 4 years, the sharp increase of the demand for vaccine has far exceeded the supply capacity, forcing the international coordination mechanism to make very difficult prioritization decisions and to shift from 2-dose to 1-dose strategies. The high pressure on the supply persisted over the years. And just to say, in 2025, ICG received 54 requests and delivered 51 million doses across 15 countries, which is really, really massive. So there has been very important effort from the global partners and manufacturers to scale up the production capacity. So now I think we are in a better position with more supply capacity. But the position remained fragile, mainly related to funding constraints. But this better position enable us with a global mechanism to think how we can restart preventive strategies. This has already restarted in selected countries with a careful approach to work further on reducing delays and address all the challenges. Prepositioning vaccines, looking at engaging more with the different stakeholders on how we can actually address all the bottlenecks and explore how we can bridge reactive campaigns and preventive campaigns. With MSF, and I will finish with that, we have a very good news this year that we have a vaccine stockpile that has been validated this year, which really enable us as MSF to look at how we can be more reactive, how we can protect population in a humanitarian context, how we can do targeted strategies, and how we can explore these different models that we will need. So with that, we will present 2 research with actionable insight on how we can use OCV through adapted schedule, targeted strategies to improve impact. So I would like to welcome Eve. So Eve is a biostatistician specialized in infectious disease epidemiologies, focusing now on evaluating dynamics and impact of preventive vaccination on cholera transmission in DRC. So Eve, back to you.
Bonjour à tous, je vais vous présenter notre
Hello everyone. So let me share with you our project on cholera dynamics and impact of preventive vaccine in endemic zones in the DRC. Now, this is a very high burden for the DRC, and this we can see in different contexts in the course of outbreaks in humanitarian emergencies. And here, what we do is we have to reinforce WASH and perform reactive responsive vaccination. But it can also be in the context of endemic regions, such as in the Great Lakes regions. And in this case, WHO recommends a mass preventive vaccination with 2 doses of OCV. Now, the endemic zones are associated with specific challenges, such as the high incidence, the different settings, urban versus rural. Also, the need to protect resident population, the local population who may be exposed to the outbreak. Also, to protect the IDP, the displaced population, who might show or present with greater vulnerability vis-à-vis cholera. Now, our project is to do with this question, to know what is the real-world impact of preventive OCV campaigns on transmission in endemic areas, and how can we better design future campaigns to maximize impact. Now, in order to do so, we have, with this WT call project, have various activities over 2021 to 2026 with serial vaccine coverage surveys, estimate vaccination over time, surveillance study within CTUs, also identify cholera dynamics, a case cohort study, or seroprevalence surveys just to assess the population's immunity. In order to answer this, we have two areas that have been considered, 2 endemic areas, which we selected. The first site is Goma in North Kivu. This is a dense urban site at the border with Rwanda. It's located between Lake Kivu and the Nyiragongo volcano, with IDPs. Approximately 700,000 IDPs are estimated to reach Goma in 2024. The other area is Bukama. It's a rural site. It's difficult to access. There are 2 semi-urban areas with lakes. It's close to the lakes and the river Congo. Now, let me share the results with you. So this is a period between 2021 and 2026. It was carried out in 19 cholera treatment units, CTUs, and you can see there are 4 health zones divided in multiple health areas. So the first vaccination took place in 2019-2020. Here in the CTUs represented in the hatched area. And another one, end of 2023, so another OCV campaign with 1 dose in all the health areas. So the other one, 2019-2020, it was with 1 dose and then 2 doses. Now, as of mid-2022, there were several IDPs, and in February 2022, all these camps were dismantled following the arrival of M23. So, in order to assess vaccine coverage, we had 7 surveys. The 4 first ones were carried out 2 to 3 years after the last campaigns, and we could see that the coverage rate was quite weak or heterogeneous for at least 1 dose of OCV after the first first one-dose campaign in 2023, the coverage was moderate and fairly homogeneous. And 2 years down the road, we deemed it heterogeneous and declining. 28,630 suspect cases were received between May 2021 and March 2026. You can see that highest number were reported in 2023 and 24. Half of these cases were women, and 35% under 5, 23% were vaccinated, 73% were displaced. Now, we also looked at the data of patients among these suspect cases on the basis of what was confirmed. We used a logistic regression model with random effects in the CTUs to quantify the risk of testing positive to cholera according to different factors. And it seems that vaccination is a protective factor, whereas being a displaced person and rainy season and the use of near surface water also corresponds to a significant risk. So here you can see the monthly incident curve seen in these CTUs between 21 and 22. You can see 2 incidence peaks in 23 and 24 with more than 80 cases per 100,000 inhabitants per month. Now, this time series can be broken down. And here you can see the global incidence at the top, but you can see that there is a global tendency, global trend, seasonality, and there is something that cannot be explained or accounted for, neither by a trend or seasonality. However, if you take a look at the events in Goma, you can see that the peak in cases coincide with the opening of camps, and when the camps are shut down, there is a decline. You can also see that seasonality of incidents corresponds to the rainy season in Goma. And here, on top of it, we also considered the preventive vaccination campaign end of 2023, right in the middle of the period where camps were open, and therefore it is difficult to assess its impact. Now, we also decided to use interrupted time series. So we measure the linear impact of one given event on cholera incidence versus a counterfactual scenario. And with this here, you can see what would happen with the opening of the camps in Goma in July 2022. So what would have been the incidence, as shown here with the on the black curve here at the bottom, if the camps had not been opened, and the incidence observed during the camps in blue at the top here. And in the second event that we study is the vaccination campaign with the impact over 18 months represented in light gray. Here it is estimated that there were 57 cases per 100,000 inhabitants of surplus incidence 1 month after vaccination campaign, when it is during an epidemic peak, and a global trend towards decline of less than 3 cases per 100,000 inhabitants per month after vaccination. And here, what happens after the camps were closed? So there is a decline in incidence towards the end of the period. However, it is difficult to see that there is a causal link and say that it is down to the vaccination or down to the closing of the camps. Now, we also looked at the dynamic in CTUs, in the health zones, without or without camps. Here you can see the impact in Goma, in the CTUs, here again with the opening and closing of camps. And in orange in the middle, you see what happens what happens in the CTUs in the areas that were associated with camps. And you see more than 400 cases per 1,000 inhabitants. And you can see that there are approximately the same trends in the whole city. If you look at the health areas without camps, the curve is different. Drilling down, you can see that the incidence is much lower, around 10 cases per 100,000 per month between 21 and 25, with a peak beginning of 25 in these health areas without camps. We don't think there is a significant impact of camps on cholera incidence. And the shutting down of camps beginning of 25 and therefore the fact that people were scattered over the city led to a significant increase in the incidence of cholera in the city. Now, let me turn to Bukama. With 12 CTUs included over time in just one health zone, the first preventive campaign took place in 21 and 22 in the health areas shown in with dots here on the graph. And the second campaign took place beginning of 25 with just one dose in all health areas. We carried out 6 surveys of vaccine coverage. The first campaign gave us a very high coverage, up to 89.3%. With over time, coverage decreased, and for the second campaign, a moderate coverage was obtained at 57.9%. In Bukama, 2,600 suspect cases presented in the CTUs between October 21 and March 26, and there were more cases in 24 and 25. And 48% of suspect cases were women. In Bukama, on the basis of the logistic regression model, vaccination with one dose at least is a protective factor. And the rainy season is a risk factor. Here is the monthly incidence of cholera between 21 and 26, with peaks of 40 cases per 100,000.
We see that there is also a high seasonality of the cholera incidence marked by the rain season. Following the 2-dose preventive campaign of 2021-22 here in gray, we see a trend of the incidence going down, but not after the 1-dose campaign in 2025. To quantify such changes after the 2 vaccination campaign, we use the interrupted time series approach. The peaks of incidence occur during the rain season. So we use the event rain season to quantify the excess of incidence between the model with the rain season in green and a model without the rain season effect in black. With this approach, we see a significant increase of 8 cases per 100,000 inhabitants in average per month during the rainy season. If we look at the first campaign, the difference between this average and the peak of cases is 16 cases for 100,000 inhabitants during the ongoing rainy season, but 0 for the next season. So there is a preventive impact of vaccination. For this first campaign, which was a 2-dose campaign with a high vaccination coverage. Second campaign, a single dose, and with lower vaccination coverage, we didn't see a preventive effect during the next season, with a peak of 31 then 36 cases per 100,000 inhabitants. Then we observed the health areas based on geographic characteristics. The center areas, more urban, showed the peaks only during the rainy season. No peak during the 23 because of the preventive impact of vaccination. However, in the northern health areas around the lakes and the Congo River, we find a circulation of cholera both during the rainy season but also during the dry season. And finally, the southern areas far from the lakes are almost exempt of cholera. In conclusion, with this study, we can begin to make operational recommendations in an urban context, endemic, densely populated, and with people moving around. Like in Goma, we see a high prevalence of cholera in the camps, in population living in pretty harsh conditions. It would be relevant to target the displaced people population. They're more exposed when the camps are open and after, but in order to get a high vaccination coverage instead of targeting all of the city, while of course beefing up the wash measures in the camps. In rural areas with a high seasonality of epidemic peaks, like in Bukama, preventive vaccination is efficient to prevent future infection peaks, but under optimal conditions with a high vaccination coverage and a second dose, we could consider prioritizing the populations living by the rivers or the lakes who are more exposed to cholera all year round. To consolidate those first preliminary results, we'll have more studies, more outputs, more results from passive surveillance, among other things, to consolidate those preliminary results. Thank you for your attention. I'd like to thank all the people who contributed to that study.
Merci Eve et bravo pour cette étude qui est faite dans les conditions.
Thank you, Eve, and congratulations for this study that was carried out under difficult conditions because it was in remote areas. And we don't have a lot of data on impact, so it's extremely valuable. But there are other big studies. We'll speak about them later. Now let's go to Guinea with Fabienne Nackers. She's a doctor and an epidemiologist at Epicentre. She will tell us about vaccination strategies and how to adapt them. Thank you. Good afternoon to all. I'll share with you the results of the vaccination trial we did in Conakry to evaluate the immunogenicity of a second delayed dose of cholera vaccine. Oral vaccines against cholera are widely used to control epidemics.
Le vaccin procure cependant une protection partielle.
But it gives only partial protection, particularly in young children. The standard schedule is a 2-dose, 2 weeks apart, which means many constraints because then you have to organize 2 vaccination campaigns, one very close to the other, and operationally, it's difficult to apply on a large scale, particularly in an emergency situation. So the second dose, when it is given, it's often after a longer time than recommended. And then the OCV stockpile is limited. In 2022, there was a shortage, so we adopted a temporary strategy was adopted a single dose in epidemic context so as to maximize the overall coverage of the population, even though without a second dose you have a shorter term protection. But in areas where there's still a risk of cholera, the second dose, even delayed, is absolutely essential for longer term protection. Finally, more and more data suggests that the 2-week interval between the 2 doses might not be the optimal vaccination schedule or regimen, and it might be too short to reinforce the immunity memory, which is essential to ensure long-lasting immunity. So we wanted to evaluate the induced immunity response with a second dose of oral vaccination delayed and compare it with the standard vaccination schedule.
réalisé un essai d'immunogénicité.
We did an open, randomized, and controlled immunogenicity trial. The aim was to demonstrate the non-inferiority of the immune response between the participants getting a second dose of OCV, pre-qualified UV-Col plus, that was, 6 or 12 months after the initial dose, and other participants getting a second dose of UV-Col plus only 2 weeks after the initial dose, as it is recommended. The main indicator for the immune response was evaluated on the basis of the geometric mean in the title of the antibodies,
INABA et OGAWA.
serum antibodies, at 14 days after the second dose of vaccine for the serogroup 01 and the serotypes INABA and OGAWA of 01, which are both covered by UV-Col plus. So I will present you the results. The study was in children under 1 year old to 9 years old and from 1 to 4. We had several secondary objectives comparing the seroconversion rates, the measurement of other antibodies that are specific of cholera, and the evaluation of the in the kinetics of the immune response in adults. The tolerance was also evaluated, even though we have a profile. So Conakry, Guinea, the latest Ogawa serotype epidemic dated back to 2012. The main eligibility criteria to take part in the trial was to be aged between 1 to 39-year-old, to belong to the general population, and to be in good health. Please note that not pregnant or pregnant and lactating women were not included, couldn't be enrolled. The evaluation of non-inferiority rests on the ratio of the geometric mean of the main indicator. So we will compare the level of vibrioside seric antibodies 14 days after the second dose of VCO or OCV between the groups getting a second delayed dose 6 or 12 months later and the control group getting both doses according to the standard regimen, which is 2 weeks apart. So the ratios compare the importance of the immune response in participants getting a second delayed dose of OCV compared with the group getting the 2 doses in the standard regimen. The inferiority margin is 0.67. That is
Le schéma vaccinal à dose retardée,
so it's 2/3. The immune response with the delayed dose is 2/3 of what it is in the standard regimen. So the non-inferiority could be demonstrated if the lower bracket of the confidence interval around that ratio is not lower than this margin. In other words, if it's above 0.67, and the criterion should be filled for the both INABA and OGAWA serotypes with a power of 80%, 20% loss to follow-up or failure in doing the analysis. Our sample was supposed to include 152 participants per arm, randomized individually according to an equal ratio in the 3 arms of the study and 3 age groups, 1 to 4, 5 to 15, and 15 to 39 years of age, so as to have an even distribution of ages in the trial compared with the general population in Conakry. Between July 22 and February 23, we evaluated the eligibility of 501 participants until we reached the required sample size of 456 participants who were randomized between the 3 arms. The latest visit of the last participant took place in August 24. The population with the intention of being treated included all the randomized patients who had received at least 1 dose of OCV and who had at least 1 blood sample taken after the first vaccine dose. That was the majority of the participants. The population, according to the protocol, included all the people who received both doses of OCV and who had a blood sample taken 14 days after the second dose, according to the protocol schedule. It represents respectively 96%, 90%, and 86% of the 3 trial arms, which is a good retention rate of the participants, even though it goes down with time. 47 of participants were under 15 years of age, 48 were women, 45 had an O blood type associated with a higher risk of cholera, and none of them declared or reported being HIV positive. The geometric means of the serum antibodies were comparable between the 3 arms of the trial. At the time of the inclusion, the geometric means of the same antibodies tended to go up in the groups with a second dose delayed for IGA1 and ONABA types, and those are the values that we'll use to compare the non-inferiority of the vaccination schedules with the second delayed dose. The ratio of the geometric mean and the confidence interval to demonstrate non-inferiority. The lower part of the confidence interval of the ratio should be above the inferiority margin, so it has to be above 0.67. And for all the participants aged 1 to 39, it was the case, both for INABA and OGAWA serotypes. In the group getting a second dose after 6 months, as well as in the group getting a second dose after 12 months after the first one, and both among the population that we intended to treat or per protocol population. On this graph, you have the results for children aged 1 to 9 years of age, and you can have the same interpretation for serotype 01 for those children. And those data are for children aged 1 to 4, and same interpretation, despite the fact that the sample size is quite limited in this age group. Those results show that the vaccination schedules with 6 or 12 months apart between the 2 OCV doses immunologically are not inferior to the standard regimen, which is a 2-week interval for the serogroup 01 and the major serotypes OGAWA and INABA. Longer intervals between the 2 doses of Uvicol Plus are a viable alternative to the conventional regimen. It could even promote a better immunity memory, therefore ensuring longer-term immunity. Those results match the observations of previous studies on the immune response after a second delayed dose of OCV. It was done in Cameroon or DRC and India. So our results reinforce that with solid evidence, encouraging a strategy of a single dose, more flexible with longer intervals between the 2 doses when you have epidemics. That's for serogroup 01. And the initial response is based on a single dose strategy during outbreaks, and the second dose will be delayed without compromising immune protection on the longer term. Many thanks to the people who took part in that study.
Merci Fabienne, ça c'est vraiment ce qu'on attendait.
Thank you, Fabienne. That's exactly what we expect from Epicentre. You know, very operational issues and work on it. Do we have questions in the room? Among people connected online with us and streaming? Okay, there is a mic, and please use the mic to ask your question.
Merci. Merci.
Thank you.
Merci beaucoup, Fabienne.
Many thanks, Fabienne. I have a question. It has more to do with the context In that setting, when you have an epidemic after the first dose, what is the impact of the epidemic? Does it have a boosting effect that may delay even longer the actual second dose of the vaccine? Or do you still stick to a 2-dose vaccine, whatever the exposure to vibrios in case of an epidemic?
Bon, alors je pense qu'on peut répondre peut-être ensemble, mais
Well, maybe both of us can answer, but
la première dose,
well, the first dose here,
pas démontré ici, mais a une efficacité
we didn't demonstrate it here, but has a short-term efficacy,
a priori démontrée comme étant quasi égale.
which is demonstrated as being equal
Donc,
for the
moi,
2
j'aurais
doses are over at least 6 months. So I would tend to think that
deuxième dose,
you can delay the second dose indeed.
l'épidémie survient juste dans quel délai? Parce qu'ici, par exemple,
Then it depends when the second outbreak happens.
après 3 mois,
But a second dose was administered anyway after 3 months. Here we talk of 6 and 12 months respectively. So this calendar is probably, or this regimen is applicable with that calendar, even though an outbreak can happen between the 2 doses. There are a couple of things we know. A single dose will not protect you for very long. So if you're talking of a response to an active epidemic, and if after that you're not in a hyper-endemic area, you're not very likely to have a second outbreak, so why not do just 1 dose? But if you're in an area like Goma, every year you have cholera cases, so vaccinating with only 1 dose will give you only a short protection, and then so you need the 2 doses because immunity goes down after a few months. Even if you delay the second dose, you still get good protection for 2 or 3 years, I would say. There was a time when we had to do a single dose, and that's the value of Ev's study, the study Ev presented. When you don't have enough vaccines, how do you prioritize? How do you select whom to vaccinate in priority? In an area like Goma, it's better to do 2 doses in well-identified zones that are at high risk rather than sprinkle, 2 doses all over the city. Those are good operational recommendations that help you to sort it all out. When there will be vaccine shortages. The Sanchol, would you have the same results as with the UV-Col Plus?
alors, je pense qu'il y a eu des études qui comparaient les
Well, some studies have compared the two. It covers the same serotypes.
tout à fait équivalentes. Donc,
So I think it's pretty much the same thing, and we can transpose the results, for Sankol. It's the same vaccine. Shankol was stopped, and we thank Sanofi for stopping the production of Sankol.
Est-ce qu'il y a d'autres questions? Non?
Online non plus. N'hésitez pas à poser des
Okay, no question online, but please do ask your questions.
C'est-
Well, you can do vaccination. You can also do wash, water, sanitation, hygiene.
Non, non.
Anything to add at this point? Nope.
Eh bien, merci aux deux.
Okay. Well, many thanks to both presenters. Congratulations, and keep up the good job with cholera.